Integration by parts. In this section, we describe one more method of integration that is found quite useful in integrating product of functions. So, this is used for integrating product of functions. Suppose we are having two functions, say u and v. U and v both are functions of x, both are functions of x, or they are constant. So, in that case, the formula to integrate is given like this: u v dx equal to u into integration of v dx minus du by dx. Will differentiate u, then multiply by integration of v dx, and this whole will integrate. So, that is respect to x. So, that is dx. So, the formula is again here: u v dx is equal to u into integration of v dx minus du by dx into integration of v dx, and then dx is at the end. And suppose sometime only there may be one function. If, so note, if there is only one function, if there is only one function, say u, then we take second function v as, then we take second function v equal to 1. So, v is taken as unity. So, sometime there may be that we have to integrate a function by parts, but there may be only one function. In that case, we will take the second function as 1. And one important rule we have to remember is that there is the rule of ILATE, I-L-A-T-E. So, first of all, let us write what is the full form of ILATE. I stands for inverse trigonometric function. Inverse trigonometric function. Trigonometric function. Then L stands for logarithmic function. So, here L is for logarithmic function. Then A for algebraic function. T for trigonometrical function. And E for exponential function. So, what is this rule? In this rule, in this order, whichever is coming first, that will take as the first one. Suppose sometime it may be, for example, the question may be like that, say integrate, just giving an example, suppose integrate, it may be x sine inverse x dx. Now, here you can see that this is algebraic function, and this is the algebraic function, this is the trigonometric function. So, what we will do in this order, so this is the inverse trigonometric function. So, in this we can see that if we see this rule, in that I is coming first and A is coming later on. So, we will just rearrange it. So, this can be written as equal to sine inverse x into A, sine inverse x into A is our x, so into x dx. So, now we can see that this is the inverse trigonometric function and this is algebraic function. So, this is in this order of ILATE, and we will be getting the answer for this. So, whenever we have to integrate by using the rule of integration by parts, we have to follow the rule of ILATE. So, that helps us a lot. Integral of the type e raised to x fx plus f dash x dx. So whenever we have uh, a function in which we are integrating ex fx plus f dash x, so the answer of this will be equal to e raised to x fx plus c. In this one, if we integrate it by parts, so it will be we'll see that on solving it, e raised to x, the integration of e raised to x f dash x will be cancelled out, and we'll be finally getting the answer as e raised to x fx plus c. So here this will not be coming. So final answer will be only e raised to x fx plus c. So this is our answer. So how to solve this is very simple one. Suppose this I is given to us. So just we have to identify fx, and then check whether f dash x is given or not. Identify fx and check whether if f dash x is given or not. Check f dash is given or not. Given or not. If it's given, then simply we have to write let fx equal to this, and then therefore f dash x equal to this, and then directly you can write down this formula. That is, the integration of e raised to x fx plus f dash x dx is e raised to x fx plus c. So now we will be going in the exercise of this topic. Question 1, exercise 7.6. So we have to integrate x sin x, and here two functions are being multiplied, so we'll use integration by parts. So first of all, let us write down this question. Integrate solution 1 solution. So integration of x sin x dx. So let us here, this will be our rough work. Elate, let us write down here elate, and check this x is actually, this is algebraic, and this is trigonometric function. So algebraic is coming first and trigonometric is coming second one. So the order is correct. There is no need to change the order. Now we'll write down. We know that. Let's write down the rule. We know that integration of u v dx equal to u into integration of v dx minus integration of du by dx will multiply the integration of v dx, and we have this all will integrate with respect to x, that is we'll write here dx. So therefore we can say that suppose this or I, so therefore I equal to, so this is our first function and this is our second function, that is this is u and this is v. So x integration of sin dx minus differentiation of x, that is 1 into, then we'll integrate sin x dx, so that you will not write directly sin x dx, then here of course dx is there, then therefore I equal to x. Now integration of sine is minus cos x, so minus cos x, then minus, here integration sine will remain as it is, then 1 will not make any difference. Now integration of sin x is minus cos x, so it will be plus cos x dx. Therefore there is no need to write here c, at the end we write therefore I equal to this, therefore symbol I equal to minus x cos x plus, now integration of cos is sine, so this is sin x plus c. So this is answer of question number 1, exercise 7.6. Now question number 2, exercise 7.6. So solving second one, integration of x sin 3x dx. So same way as the earlier one, first we will write here elate and check whether it is in that order or not. So first one is algebraic function, second one is trigonometric, so we have not to change the order. So now we know that, we'll just write down the rule. We know that integration of u v dx is equal to u into integration of v dx minus integration of u into minus integration of, this will be du by dx multiplied by integration of v dx and dx. So therefore suppose this I, we can say therefore I equal to just putting this, we'll be getting x integration of sine 3x dx minus difference in the first function, that is dx by dx into integration of sine 3x dx, and this will be dx. So therefore we can have I equal to x into integration of sine is minus cos 3x, so this will be minus cos 3x, and of course coefficient of x is not 1, so we will divide by the difference of 3x, that is 3 minus, so this will become again here also we will be getting minus cos 3x by 3, so minus is here, it will become plus 1 by 3, and this will become cos 3x dx equal to, therefore we can say I is equal to minus x by 3 cos 3x, then integration of cos is sine, so plus sine 3x over 3 already, and because the coefficient of x is not 1, we will differentiate 3x, so we will be getting here 3 and plus c. So our final answer will be, therefore I equal to minus x by 3 cos 3x plus sin 3x over 9 plus c.
Question 3, exercise 7.6. Integrate x square e raised to x. So let us solve question number 3. Solution 3. Integration of x square e raised to x dx. Here let us first write down the rule of ILATE, I-L-A-T-E. Here we can see that x square is algebraic and e raised to x is exponential function. So a is coming first and e is coming later. That means they are in order. So there is no need to interchange them. Suppose this is I. So I equal to, now you will be using the uh, formula of integration by parts. So we'll get I equal to x square into integration of e raised to x dx minus integration of, then we'll differentiate x square, that will become 2x into integration of e raised to x dx, and then integrating this with respect to x. So therefore I equal to x square e raised to x minus 2 can be taken out, and this will become x e raised to x dx. Here because integration of e raised to x is e raised to x, so we have written here e raised to x. This is not this dx, because this on integrating will give us e raised to x, so this is e raised to x, and then we have this dx. Now here also we are seeing that we are having two functions being multiplied, so we'll again use the method of integrating by uh, parts. So let us suppose, let this be I1. So let this whole be 1. So let I1 equal to integration of x e raised to x dx. So therefore I1 will be equal to, let us see that this is a and this is e, so they are in order. There is no need to interchange them. So this will be I equal to x integration of e raised to x dx minus integration of, then first we'll take differentiation of x, that is 1, multiplied by integration of e raised to x dx, and then dx. So this will give us I equal to x into e raised to x minus, and here when we integrate e raised to x, we will be getting e raised to x into 1, there is e raised to x, and then again integrating second time e raised to x with respect to x, we will be getting e raised to x, and let this be say 2. So putting this I1, so putting 2 in 1, we have, so what we will be having, I equal to x square e raised to x minus 2, and in place of this we will be putting the value of I1, that is x e raised to x minus e raised to x, and plus c. Here constant we can write combined constant of 1 and 2 will be say plus c, and Therefore, we can say that I equal to, from this, let us simplify this, x square e raised to x minus 2x e raised to x, and this will become plus 2 into e raised to x. Now we can keep this as it is, or we can take out e raised to x common. So therefore, I equal to taking e raised to x common, will be getting x square minus 2x plus 2 plus c. So this is the answer of question number 3. Question number 4, exercise 7.6. So solving question number 4, solution for I equal to integration of x log x dx. So first let us write the rule of ILATE, ILATE. Here we can see that L is coming first and A is coming later on. So that means, but this is algebraic and this is logarithmic. So we'll just interchange it. So this can be rewritten as, rearranged as I equal to log x into x dx. So now this is the first function, this is the second one. So integrating by parts, therefore we have I equal to, this will be, this is the first one, so log x integration of x dx minus differentiation of log x, that is 1 by x, and into integration of x, that is x square by 2 and dx. So this will give us I equal to, here we will be having integration of x square by 2, so x square by 2 log x minus integration of, so this 1 by 2 we can take out, and this will become x dx. So therefore we will get I equal to x square by 2 log x minus x square by 2, and 1 2 is already here, so x square by 4 plus c. So this is the answer of question number 4, exercise 7.6. Exercise 7.6, question number 5, question number 6 will be for self trial. So question number 5, question number 6 for self trial, that is you have to try on your own. Now let us go for question number 7th one. So here we are having question number 7. So solving 7th one, uh, let I equal to integration of x sine inverse x dx. Now if we integrate this directly as it is, then we'll have to use a formula which is in the next exercise, so we'll avoid that one. So instead of that, we'll remove this inverse. And how we can do that? By simply putting sine inverse x as, say, theta. Let sine inverse x equal to theta. Therefore now we'll convert this whole function in terms of, we will integrate this whole in terms of theta. So we'll, from here we can have x equal to sine theta, and therefore we can have dx will be equal to cos theta d theta, and therefore we will be having I as I equal to, so in place of x we'll put the value of x, that is sine theta, and in place of uh, x we have put sine theta, and in place of sine inverse x we'll put the value of sine inverse x, that is theta, and dx is cos theta d theta. So therefore we will be having I equal to integration of theta into sine theta cos theta d theta. Now there are three quantities are being multiplied. So but we are having rule only for 2. So what we can do is we can use the trigonometric formula, that is sine 2 theta is 2 sine theta and cos theta. So just what we'll do is multiply and divide this with 2. So therefore we can say that I is equal to half into integration of uh, theta into 2 sine theta cos theta d theta, and this will become, therefore I equal to half integration of theta, and this will become sine 2 theta d theta. Now let us enlarge this. So here we are. Now let us first write down the rule of ILATE before integrating this one. So this is the rule of ILATE, ILATE. So our theta is algebraic and then this is trigonometric, so it is already in order. There is no need to interchange. Now just we'll integrate this by using parts. So let's integrate here. So we'll be just rewriting it. Therefore, I equal to, let's see what we have written. That is half integration of theta sine 2 theta d theta. Let's check it again if it is the same. Yes. So now we'll be using UV rule. So I is equal to half. So this first one, as it is theta into integration of sine, that is we'll be getting minus cos 2 theta over 2. Then minus, then we'll differentiate theta with respect to theta, that is 1. And again here integration of multiplied by integration of sine, that is we'll be having here cos 2 theta, and this will become plus over 2 and d theta. So this will become equal to, this whole is closed, so equal to 1 by 2 as it is, and this will be minus theta cos 2 theta over 2 plus, now this 1 by 2 can be taken out, and integration of cos we know is sine, so here we will be getting sine 2 theta over 2 and plus overall it will be here plus, you can write. So therefore we can say that I is equal to minus theta cos 2 theta over 4 plus sine 2 theta over this, 2 are multiplying, so we'll be getting here 2 is here also, so we'll be getting 8 plus c. But here our initial question is in terms of x. What we'll do, we'll convert this in terms of x. And how we can do that? First of all, we write I equal to minus theta, and cos 2 theta we write in terms of sine, because we have taken sine theta as x. So cos 2 theta can be written as 1 minus 2 sine square theta over 4, and here plus this also can be written as 2 sine theta into cos theta, and cos theta can be written as square root of 1 minus sine square theta, the whole divided by 8, and we have plus c. Therefore now we can easily rewrite our this value which we have got in terms of x. So I is equal to minus, from here we can get theta is minus sine inverse x 1 minus 2. So this will give us sine square x, sine square theta is 2x square over 4, and plus 2 sine theta is, sine theta we have taken as x, so plus 2x into square root of 1 minus x square over 8 plus c, and here we can do the simplification, so it will become here 4. So this will be our final answer, that is I equal to minus sine inverse x into 1 minus actually this is like this, so minus sine inverse x into 1 minus 2x square over 4 plus x into root of 1 minus x square by 4 plus c. So this is our final answer, and this is the answer of question number 7. Question number 8, question number 9, 10, 11, 12, that all you will do on your own, that there will be questions for self trial. So self trial questions, self trial will be question number 8, question number 9, then 10, 11 and 12. So now what we'll be doing is we'll be doing question number 13. So let's solve question number 13. So solving 13th one, so we'll do this. That is I equal to integration of tan inverse x dx. So here let us do it as we'll be trying to avoid inverse function. So let us take tan inverse x as say theta. We'll be getting therefore x equal to tan theta, and therefore differentiating both sides with respect to theta. This is actually theta only. This is not phi but this theta. So differentiating both sides with respect to theta, will be getting dx equal to sec square theta d theta. So let this be suppose equation number 1, and this be 2. So putting 2 in 1, we have putting 2 in 1, putting 2 in 1, we have, and let us enlarge this one. So here we have putting 2 in 1, we have I equal to, so this will become uh, in place of tan inverse x will be writing theta, and in place of dx will be writing sec square theta d theta. So if we compare this now, if we write the rule of Elate, there is ILATE. This is only rough work. So A is theta, so it is coming first, and then T is trigonometric function, so it is coming later. So it is already in order. Now just we'll use UV rule. So therefore I equal to theta into integration of sec square theta d theta minus, we'll differentiate this, so theta that we will be getting 1 into integration of sec square theta d theta. So we'll be getting, therefore I equal to theta into integration of sec square theta is tan theta minus, this will become tan theta d theta. Therefore I equal to theta tan theta minus integration of tan theta is log sec theta plus c, log mod of sec theta plus c. Now our initial function is in terms of x, so for that what we'll do is we'll convert this sec in terms of tan. So we are having I equal to theta tan theta minus log sec theta can be written as, we know that 1 plus tan square theta is sec square theta, so it can be written as square root of 1 plus tan square theta plus c. Therefore we can say that I equal to theta is tan inverse x and tan theta is x, so we can write x tan inverse x, this tan theta is x and theta is tan inverse x minus log, and modulus of here tan theta is x, so we can rewrite this as square root of 1 plus this will become x square plus c, and therefore I equal to x tan inverse x, and root means we know power is 1 by 2, so minus half log modulus of 1 plus x square plus c. So this is the answer of question number 13. Question number 14 and 15 will be for self trial. So that means you will try them on your own. So now let us go in exercise 7.6, question number 16. So we are having question number 16, 16th one. So solving question number 16, solution 16, I equal to integration of e raised to x sin x plus cos x dx. So whenever we are having we have to integrate a function with e raised to x, it is better to check whether it is of the form e raised to x fx plus f dash x or not. So here let us try that one. Let fx equal to, now we know that differentiation of sine is cos, so let fx equal to sin x. So therefore f dash x equal to cos x, and also we know that I equal to the integration of e raised to x fx plus f dash x dx is equal to e raised to x fx plus c. Only what we have to prove that with fx we are having f dash x also in the bracket. So here we have proved that with sin x we are having cos x also. So that means what is the answer of our question? Therefore I equal to e raised to x, what is our fx, sin x plus c. So this is the answer of question number 16. So with this question number 16 is complete. Question number 17, exercise 7.6. Let us solve. Here also we are having e raised to x. So let us check whether it is of that form or not. So solving question number 17, I equal to integration of x e raised to x over 1 plus x whole square. So directly we are not getting it as the form of fx plus f dash x, because here we are having only one function multiplying with x. So let us see if we any modification we can do in this one. So we'll be getting, therefore I equal to, what we can do is we'll keep e raised to x as it is, and in x we'll add 1 and subtract 1. So 1 plus x minus 1 over 1 plus x whole square dx. So I equal to e raised to x 1 plus x over 1 plus x whole square minus 1 over 1 plus x whole square, and then dx. So I equal to, which we are getting it, let us just expand this one. So we are getting here I equal to integration of e raised to x multiplying 1 over 1 plus x minus 1 over 1 plus x whole square dx. Now let us take, let fx equal to, we have to choose wisely which is on, we have to select as fx. So it is clear that we know that difference in 1 by x is minus 1 by x square. So we will be selecting 1 by 1 plus x is fx. Let fx equal to 1 over 1 plus x. Therefore f dash x equal to, now differentiation of this we can rewrite this as 1 plus x raised to minus 1, and that will be equal to minus 1 over 1 plus x square. So therefore I is of the form, I is of the form I equal to integration of e raised to x fx plus f dash x dx. Therefore we can say that I equal to, what is our I, e raised to x into fx. So e raised to x into fx. What is our fx? Fx we have taken as 1 over 1 plus x. So plus c. So this is the answer of question number 17. Question number 18. E raised to x into 1 plus sin x over 1 plus cos x. So integrating this function, solution of 18th one, I equal to integration of e raised to x into 1 plus sin x over 1 plus cos x dx. Now let us check whether this can be written in the form of e raised to x fx plus f dash x or not. So I equal to integration of e raised to x, let us separate the 1 plus sin x can be written as 1 plus 2 sin x by 2 cos x by 2, and denominator can be written as 1 plus cos x can be written as 2 cos square x by 2, applying trigonometric identities. So dx. So therefore I equal to, let us expand this space. So we are having I equal to integration of e raised to x. So this will be, just will separate them. We will be getting here 1 by 2 cos square x by 2 plus 2 sin x by 2 cos x by 2. Here dx will be there over 2 cos x by 2 into cos x by 2. Writing cos square x by 2 as cos x by 2 cos x by 2. And cancelling cos x by 2, cos x by 2 and 2 and 2. Therefore we are having I equal to, this will become integration of e raised to x, and this is our x. So writing at e raised to x and half as it is, and we know that cos square 1 by cos is sec, so it will become sec square x by 2. So sec square x by 2, and plus, so this will become 10x by 2, and here dx. Now we can clearly see that if suppose we take 10x by 2 as fx, then differentiation of that will be equal to half sec square x by 2. So that is what we'll do. Let fx equal to let fx equal to 10x by 2. So let this be 1. So therefore f dash x equal to, differentiation of this will be sec square x by 2, then will differentiate x by 2 will be getting half. So, and that is equal to half sec square x by 2. So here we can see that this is our fx and this is our f dash x. So we can say clearly that 1 is of the form, therefore clearly 1 is of the form, therefore clearly 1 is of the form I equal to integration of e raised to x fx plus f dash x dx. So therefore what we can say that therefore I equal to e raised to x into fx plus c. So this is our answer. Therefore I equal to e raised to x. What is our fx in this case? Our fx is 10x by 2. So we'll be writing here 10x by 2 plus c. So this is the answer of question number 18. So with this 18 is complete. Question 19 will be for self trial. So that is you will try on your own. Now let us do question number 20. So solving 20th one, solution 20, I equal to integration of e raised to x into x minus 3 over x minus 1 whole cube dx. Let us try to see whether it is of the form e raised to x fx plus f dash x or not. So in the denominator we are having x minus 1. So we'll rewrite the numerator in that form. So therefore I equal to integration of e raised to x into x minus 1 minus 2 over x minus 1 whole cube dx. Now we'll separate it. Therefore I equal to integration of e raised to x, here we will be getting 1 over x minus 1 whole square minus 2 over x minus 1 whole cube, and this is dx. Now let us first enlarge this one. Now we know the differentiation of 1 by x square. Suppose we are having 1 by x square, that can be x raised to minus 2, and the difference that is minus 2. This is minus 2 over x cube. So that is what we are having here. So what we'll do is we'll take this as our fx, and then we'll differentiate that, and we'll be getting here the remaining as f dash x. So let fx equal to 1 by x minus 1 whole square. So now this all is rough. This all was rough work. So therefore f dash x equal to, this can be written as here we have discussed in the rough work, this can be written as x minus 1 whole raised to minus 2. So that is equal to minus 2 over x minus 1 whole cube. So therefore I equal to is of the form e raised to x fx plus f dash x here dx. Therefore we can say that I is equal to e raised to x into fx plus c. Therefore I equal to e raised to x. What is our fx? Our fx is 1 over x minus 1 whole square. So 1 over x minus 1 whole square plus c. So this is the answer of question number 20. Question number 21, 22, 23, 24, and so this all will be questions for self trial. So question number 21, 22, 23, 24, they all are for self trial, that is you will try on your own. And so with this the exercise is complete.